Hi, today we are presenting our report on investigating electronic and rock track genres from the Free Music Archive. So to briefly introduce the Free Music Archive dataset, this dataset was released in 2017 to provide an easily accessible dataset for music information retrieval. The dataset came in three tables, the genres, features, and tracks table, but our report only used the features and tracks tables. The most relevant variables we used in our report were the track ID and track genre variables, which came from the tracks data table, and the danceability, energy, speechiness, and instrumentalness variables, which came from the features table and were values from 0 to 1 that represented a musical nature of the track.
To further our exploration, we came up with both a hypothesis question that we could test and a prediction model. Our question was, is there a difference in the distribution of danceability scores for songs in the rock and electronic track genres? Our null hypothesis was that distributions of the danceability scores for the rock and electronic track genres were the same, and any difference between them was due to random chance. Our alternative hypothesis was that songs classified under the electronic track genre had a higher danceability score than songs classified under the rock track genre. Additionally, for our prediction model, our goal was to build a k-nearest neighbors classifier that categorizes songs as either rock or electronic music through comparing that song's particular features. We specifically utilized 4 different features for this, and we used 13 k-nearest neighbors to compare our songs with. Our exploratory data analysis, the first thing we did was we merged the track and features table, and the purpose of this was to give us a method of comparison between rock and electronic music. Additionally, the insights that this gave us was that it allowed us to notice important features that had large differences in means. For example, we saw that there was a large difference in danceability means between rock and electronic musics in this table.
The next data table that we created was an aggregated table based on the track genre and the danceability means. So we were able to find the danceability mean for each track genre. We needed this because we needed the mean danceability for each track to investigate the relationship between all the different tracks. The main insights is that out of the 11 track genres, electronic has the 3rd highest danceability, while rock has the 2nd lowest danceability, which shows how far apart they are relative to the number of tracks.
Additionally, using the table we discussed on the previous slide, we created a visual representation in the form of a qualitative bar graph, and this allowed us to visually compare differences in mean danceability for different track genres. This was very insightful to us as it showed us that genres that share musical elements have very similar danceability scores. For example, hip-hop and electronic music share various musical elements, and they have very similar danceability means.
Finally, we created a stacked histogram to gain intuition about the A/B test. We plotted the distribution of electronic and rock track genres and the danceability. This allows us to visually see the difference in the distributions, and the main insights are that the two distributions are not similar at all, and that electronic tracks have lower danceability than rock tracks, which gives a little bit of support to our alternative hypothesis. Next, we carried out the actual hypothesis test. Our null hypothesis, again, was that the distributions of the danceability scores for the 2 track genres are the same, and any difference was due to chance. And the alternative was that electronic track genres have higher danceability scores than the rock track genres. We used a standard A/B test with a 5% cutoff, and our test statistic was the difference between the electronic mean danceability and the rock mean danceability. From the histogram that was generated from the A/B test, we can see that most of the values were between -0.06 and 0.06. However, our observed test statistic was 0.16, and as a result, our p-value was 0.0. This allows us to reject the null hypothesis and conclude that songs classified as electronic have higher danceability than songs classified as a rock.
Additionally, for our prediction model, as we stated before, we used a k-nearest neighbors model to classify songs as either rock or electronic music. How we did this was we created a table consisting of all features for all songs that were strictly rock and electronic, and we divided this into a training and testing set. We utilized the features of danceability, energy, speechiness, and instrumentalness to classify our song, and we used 13 k-nearest neighbors. We used these features and this number of k-nearest neighbors as it allowed us to gain the highest accuracy percentage possible, and this percentage was 83.33%.
Overall, we thought that our report was pretty cohesive and allowed us to find differences between electronic and rock track genres. Our A/B test showed that there was a difference in the danceability distributions between electronic and rock genres, and this allowed us to build a classifier with danceability as well as other features which had a relatively high accuracy. One potential limitation was that the genres listed in the dataset were listed by the authors themselves, and there might be some gray areas. So a way to mitigate this would be to cross-reference genres of incorrectly classified songs with another external dataset. Thank you so much for listening to our presentation.